We are starting this meetup. We are going to talk about Docker, Sitecore, and the new developments that are being carried out in this moment. Thank you for joining. The Sitecore user group is a young user group, and we hope that our small contributions help the community. Let's start by telling who we are. We are a new Sitecore user group. We are located in Alicante. Alicante is a well-known place for beach and holidays. Our main sponsor is Clear People. Clear People is a Sitecore Gold Partner and is also Microsoft Gold Partner. This is me. I'm Benjamin Mols, Sitecore developer in Clear People. And those are my details in case you have questions or you want to ask anything about Docker or Sitecore. Let's see what we are going to see in this presentation. We're going to do an introduction to Docker for those who don't know Docker, are not familiar with it. It's going to be pretty high level, pretty simple without getting into details. And later we're going to start with the demo. In the demo, we are going to show how to set up a development environment. The situation that we are going to showcase is going to be a new developer that is joining a team that is already developing. So we have a project within source control, and we want to showcase how a new developer can create a new development environment, pulling the information from the source control. We will show how to debug also Sitecore issues within a container, which is one of the most common things that we normally do when we work with IIS. Okay, what is Docker? Docker, in a very simple way, is a technology to create containers. Basically, Docker is the technology and also the company behind the technology. And what is a container? Is the next question. A container can be defined in many different ways, but from a developer point of view, the easiest way to understand quickly what is a container is comparing it with a virtual machine. A container is very similar to a virtual machine. The main difference is that in a virtual machine, we always have to install an operating system. So if we have 3 virtual machines running in a development environment, in a box, we need 3 operating systems. And normally those virtual machines are heavy, because even without installing anything such as Visual Studio or such as SQL Server, the machine already takes quite some space. Docker the containers work as virtual machines, but they do not have their own operating system. They share the hosting operating system. That provides several advantages, but in a nutshell, that is the main difference. When we use container, we use them in a very similar way as we use virtual machine. We have a software running like IIS or SQL Server within the container, and they provide a service similar, like if we had one virtual machine with SQL Server, the container is going to behave in a similar way. How does it work? In order to understand how containers work, we need to know basic concepts. And I've selected the most basic ones. The center of the image here is also called images. I would say that images is one of the most important concepts in Docker. From a developer point of view, the easiest way to see an image is like a class in object-oriented programming. It's same as a class is the definition of an object. An image is something like that. It defines the common properties and common software for a container. They are static. They do not change. They do not run. They are just something stored somewhere. And the container is the instance created based upon the images. The containers behave as an object in object-oriented programming. So when we want to use an image, basically what we do is we instantiate a container based on that image. And another concept very important is the concept of repository. One repository is a store of images. The good thing of one repository is that we can create images which normally are heavy, normally take some space like a virtual machine, similar to a virtual machine, maybe lighter, but it still might take several gigs, and also might take a little bit to build. So once it is built, we can store it in a registry. That allows us to have several developers pulling from the same images. So once you build the image, then you can reuse it once and again without having to build it again. So it's a very convenient way to work. We can have different kind of registries. Some registries are public, other registries are privated. Examples of public registries could be Docker Hub, is very common. We can also create in Azure our own private registry that allow us to create images that are all going to be used and accessible only to our company. Advantage for developers. Docker might have advantage for many people in DevOps, for infrastructure, and for other stuff. But thinking of developer, the advantage I see is that it can help to put not only the source code of the application, but also the definition of the environment in source control. This allows us to document the environment. It is clear what is needed to run a specific piece of work or piece of software. We can easily share it because you downloaded the code defining that development and you can create it from scratch. And also version control. You can change something and go back to a previous version very easily. You just instantiate a new container and that's it. It is efficient for several reasons. Firstly, you need less space in the disk to store them than what you would need for a virtual machine. They start faster because you do not need to start an operating system. The operating system is already running in the host. And also need less maintenance. You do not need to install patches. You don't need to install on each single container. The patches are installed on the host, and that's it. It can also simplify our lives when we are doing deployments. Normally, the developer defines how a piece of software has to be deployed, and sometimes we run into issues because our environment is different to the QA environment, or the QA environment is different to the UAT environment, because last person who was working with the UAT left something that was not expected, and then we get into the surprise. And when this happens in the production environment, it's critical because it might be affecting the end user. So all those kind of issues can be reduced, if not completely removed, by using containers. So this might save some bad moments at some points. Now we're going to describe what we are going to demo. We have said that we're going to set up a development environment and we are going to debug Sitecore within a container. The process of set up the environment has three steps, main steps. The first one is the building of the images. However, this step is very simple to do. It's just run a command and we will see it later. But it takes, building the images might take maybe 1-2 hours depending on the amount of images that we are building. So we cannot show it right here because we will be waiting for too long. So basically what we are going to do is we will describe how to do it, which is very simple. Later we are going to see as well how to create the project, how the project look like, just to create a starting point which would be the same for absolutely every project. This will have only out-of-the-box Sitecore installation. And at the end, we will show how to install within the local instance of Sitecore. We are going to install the customization that has been already implemented by previous developers in the project. This is highlighted because this process also takes a little bit of time, and it might take around 5 minutes or something like that. So we will start doing this so that meanwhile this process is running, we will give it some time by explaining the details of the project. We are going to use, in this project, 2 new repositories that have been created very recently by Sitecore, and they are being developed by the community. I would recommend you to check them out because they are very interesting. Here we are going to start with the initial Visual Studio setup. This is the process that we have said that might take a little bit of time, so we are going to start it so that we do not have to wait later for it. What we are going to do? We are going to go to GitHub. We are going to clone this repository. Okay. Let's open it with Visual Studio. We have it already here. Okay. So this is a very basic example. This example is within the repository. This example has 3 projects. One that will define the environment of the different containers that we will need to run Sitecore. This is going to be a very basic TDS project where we have serialized the items that are being developed within Sitecore. And this is the standard web app that we are going to deploy to manage the code, the customization of Sitecore. I'm going to introduce, this is the structure of the repository. We are going to use the TDS sample. This is the solution folder, and I'm going to introduce this folder, the storage folder. The storage folder is going to have the data of the container of the whole environment. In a Sitecore website, we have normally a data folder and a website folder with the files of the site. Let's create several views of this folder. So this folder, the data folder, is going to hold all the data of the project. We need here our license file. License files is something that each partner has, so it cannot be in the repository. Here in this folder, we are going to hold the databases. Here we are going to hold the indexes, the Solar cores. And here we are going to store the files for our website. There is one change that we want to do in the website project. Here in the publish profile, we have a sample profile, and we are going to create one profile for our specific developer. Let's have a look and confirm that the publication profile that we just created, we see the settings, and we confirm that is pointing to the storage folder, website folder, where we are going to publish all the files, all the output of this project. Everything is fine. One additional step that we need to do is here in the Docker Compose. Sorry, no, it's not here, it's here. In the Docker file, Here is where we are defining the container of Sitecore. And here we need to specify the name of the image that we are going to use. This name has to be assigned by ourselves when we create the base images. Okay, as we didn't do it yet, we are not familiar with it. We will see it in a few minutes. But just for you to be aware that one of the steps that we need to do is come here and choose the name that we are going to use to create the images. We will see it when we create the images. So basically we need to update this file and we need to update also this file. We have two files because this file is the one that defines the container that we will use in development, and this will define the container that we are going to use in other environments. We will see now what the difference is, but just bear in mind that we will have like two configurations, one for debug and the other for release, and we will have one container for debug and one container for release with very small differences. So I'm going to set up this project as a startup project, and I'm going to run it. Now this is going to create all the containers that are needed to run Sitecore. It's going to create 3 containers. Meanwhile this process is running, let's go back to the presentation. This is the structure of the containers and images that we are going to use. There are like 3 levels of images and containers. The upper level is the standard containers managed by Microsoft and by Docker. One container is going to have ASP.NET, AJS with ASP.NET. Other container will have a plain SQL server with no databases, just the server installed. And another is going to have the Java platform required for running Solar servers. The second level is the level of the images that have been created in the repository, in the Sitecore repository. These will be standard images and will be reused by all the community. We will have images for every specific version of Sitecore. We will have images for SQL. This image with SQL will be basically inheriting this base image. However, it will have already the Sitecore databases already installed. And the Solar will be very similar. It will be inheriting from the Java platform, so it will have the Java platform by inheriting, and we'll add the Solar and the Solar cores. The Sitecore instance is going to have the out of the box Sitecore files. The last layer is going to have a website container, which will inherit from this. Here we will add all our customizations. Here we will have another container, which will be a SQL container, and this will have the databases with all the customization that we want to add to the solution. And here we will have the cores with also the customization from these databases. So basically, these 3 containers are going to be the containers that we are going to be using in the demo. Now, we're going to focus on this last layer. We are going to see the details of the last layer. Microsoft will take care of this. The community will take care of this. And we as developers will be responsible for the last layer. So let's understand it a little bit more. Here we have the three containers: the website container, the SQL container, and the Solar container. In Docker, in the Visual Studio, as we have seen a moment ago, we have files that define the container. So basically, every time that we open Visual Studio, we will create new containers from scratch. However, we want the databases to keep the information from previous tests or from previous debugs. We don't want to be reinstalling Sitecore items every single time. The same happened with the data folder, and the same happened with the web folder. So what we are going to do, we're going to use a feature from Docker. It's something called volumes, and it allows us to map one internal folder in the container to an external folder in the host. This would allow us to have these 4 folders in the host environment so that we can persist the information for this specific project within the solution folder. So these are the folders that we have seen when we have seen the introduction to the Visual Studio solution. The container will pull from these different folders. This is going to be with the development composition. The release composition is slightly different. We have our 3 containers, and the difference is that the website folder is not anymore in the host. We are embedding it in the container. This will make our life easier when we want to deploy the container to other environments. So the container will have everything it needs to run. Only the data will be outside the container, allowing us to remove the container and create a new one without issues. So let's start now with the demo. Well, here we have Visual Studio is finishing building the container. Here I am expecting an error. So this window will end up in an error. Exactly. This is what is happening here. Visual Studio has created the 3 containers. Let's see it. Let's see it here. Here is the SQL, the Solar one, and the TDS sample, which is the project one. However, once Visual Studio creates the container, it tries to attach to the container. However, the container is still not ready because when the container is starting, it's doing some work for us. If we go back to the previous folders, we can see that the database folder has been filled with the databases. The Solar folder has been filled with the indexes or the cores. And the website, it's being filled with the files from Sitecore. And as we can see, we do not have yet all the files. So this is one of those moments where we might need to wait for a few minutes to get this folder completely filled. One thing that I can tell is that this IP that we have here is the IP of our website container. So if we come here, we can come here. And well, the site is still not running because the files are not yet copied locally. In the meantime, let's see how we would create the based images from the GitHub repository. Let's go here. Let's go to GitHub, Docker images. In this repository, before we were using the Docker demo. Now we are using Docker images, which is storing the standard Sitecore images. We need to clone it. In fact, I've got it already cloned. We don't have to wait for that. I have it here. Here we have one image for each version and each container that we need. We have one for Solar, one for SQL, one for a content delivery, and one for a content manager for this specific version of Sitecore with this configuration. And here we have again one Docker file defining this image. And what we need to have the image available is running one command I'm going to show you. Here I've got some PowerShell scripts. Basically, all of them is the same command with different parameters. This is just to make it easy for me. This allows me to build everything from version 9.1. So let's have a look how it works. So this command, we need to tell where is the repository. We need to tell where it can find the zip files required to build the images. Also, the license file needs to be there. We need to tell the name of the organization that is doing this. This is this is not strictly necessary. This is only when we want to store this in an internal privated repository. This is the name of the repository. And this is to tell if we want to push the image to the repository or no. I normally use this for development because it's just faster. And here we have a filter which tells what you want to build. So with this filter, you can build everything that is version 9, or you can go to the version and the configuration, or by choosing the filter, you can decide how many images you want to build. So just by running this command, and you need to wait for quite some minutes, maybe 1 hour, something like that, depend on the machine, on 1 hour, 2 hours. It depends also on the number of images that you want to build. After that, you get this. I'm going to show you. You get a list of images. Here is where we have the name of the company. This is the name of the repository that we have passed as a parameter, and this is a tag that allows us to identify different versions if we want to identify different versions of Sitecore. So by running that, we already have all the prerequisites that we need to build and this is the name that I mentioned before that has to be set here in the Docker file and the build Docker file. So we will use one file for each configuration, one for release. This is what takes care of the differences of folder. So these commands will take care of embedding the Sitecore website folder inside the container or outside the container. Let's see if the files have been already copied. Still not. This is being a little bit slow. This is an error because files are not in place yet. Now we have all the files here. And if we refresh this, in the meantime, I'm going to copy the IP here so that we can use a URL to enter the container. Still not. We will see here that Sitecore is going to create the log folder to store the logs and all the typical folders that are created within the data folder. Okay, now we have the logs created. It is warming up. We can see that we can access the same information as if we had the project running in IIS locally. If we modify anything here in the website folder, it will automatically be detected by Sitecore, and Sitecore will restart exactly the same as if it was IIS. Okay. So what you can see here is just out-of-the-box installation of Sitecore. You can see that the only thing we did was running from the solution, just from here.
Ben, maybe in the meantime, we have a question. I'm not sure if you want to answer that one.
Yes, thank you, Petula.
So the question is, why does the Docker Compose file contain the image information for the website container, but the Docker file as well? Isn't that redundant, confusing?
It might be confusing, but not redundant. When you see carefully the information that is stored in each place, you will see that it's not exactly the same information. From a developer point of view, the Docker file is the implementation of a method in an object. And the Docker Compose is the usage of that method from outside. And also, the same as one method, one function can have parameters, we can define parameters in the Docker file, and those parameters can be provided from the Docker Compose. And this allows us to define, for instance, we might want to have 3 instances of one content delivery. So we would have one Docker file defining the content delivery, and by passing parameters from the Docker Compose file, we would be able to instantiate 3 services, 3 containers using the same Docker file. Let's see an example. Here, for instance, we have the Docker Compose file for release and for debug. We can see that the debug one is mapping the local storage website to the internal folder in the container. However, in the release one, we do not have that mapping. So this mechanism allows us to provide some details. Another example could be in the release, we need to provide the folder with the customization from the website project. We need to embed the changes that we do with Visual Studio. We need to move them to the container. However, in debug mode, we do not need that. So we are passing an empty folder. Okay, this is already here. Let's see that what we have now is just an out-of-the-box installation of Sitecore without any kind of customization. As we can see here, we have a content node with a home, and there is nothing inside. Now we are going to start the second stage of the presentation. We have seen how to build the images. We have seen how to set up the development environment. Now we are going to deploy our customizations in the project. How to do that? Let's go to the project, the TDS project. This, what we are seeing here, is just the basic configuration of a project, of a TDS project. And now we are just going to test that everything. As the website folder is local, TDS is able to check that is connected to the website, and it can connect through the URL and also through the path. This is going to take as well a little bit, so it could be another good moment. If you have any questions, we can talk about it.
I have a question.
Yeah.
It's regarding the volume mapping for the website. How that exactly works with already Sitecore installation existing in the image, and kind of mapping our build folders into that container, but already persisting somehow the content from that image and not losing the installation, basically. How that works?
It works because the base image, for the base image to be installed, needs those files. So what we do is we just leave those files in the base image. And here with the Docker files, well, I cannot show you now because it's this window working. With the Docker files that we have here, what we do is we rename the original website folder that is embedded in the container. We rename it, and then we create a volume in its place. Docker do not allow you to create a volume if the folder has any content. So in order to achieve it, what we do is we rename it, and we map an empty folder to the external website folder. And after that, we check if the volume, if the external folder is empty, and if it is, actually we do not check if it is empty. We check if there are a couple of basic files. I think it's the web config and another file in Sitecore. If they do not exist in the local folder, then we copy from inside the container all the content of the website that has been renamed to the external folder. So for the release version, we just leave the original folder coming from the base image. We don't do any change. So this is a trick we do just for development in order to achieve two benefits. One is that we make easier the installation of the local environment. And the second one is that we can do deployments locally. We can publish or copy a file or rename a configuration if we want, as if it was IIS. And we do it with a very simple trick.
Okay, it's basically but a workaround for this limitation where, if I understood correctly, that you cannot specify a volume for a folder where there's already items inside.
Correct. Docker for Linux supports that. The documentation of Docker says that the default behavior of Docker is when you create a volume, if the internal folder of the container has content, automatically Docker copy that content to the external volume. That is the default behavior of Docker for Linux container. However, for Windows container, it crashes. So what we do is we simulate that behavior by renaming the internal folder and creating the volume. Obviously, we make sure that there is nothing. And once we have the volume, we copy the content. Okay, this is done already. I can show you now. This is something that we have control over it, because you see, this is the Docker file that we use for development, and here is where we do the rename. We are renaming the site path, and here is where we copy it. Sorry, we do it with this PowerShell script. We move this PowerShell script and we run it. Okay, so it's a kind of workaround, but it works as it should work, as per my understanding.
Mm-hmm. Okay.
Does that answer your question?
Yeah.
Okay. Now we have checked that TDS can access the site, and we are going to deploy the same as we would do with any other Sitecore project with IIS. In this case, we are doing a deployment to a local folder, so it's exactly the same. Something to mention here is that when we close Visual Studio, the Visual Studio takes care of deleting the container. So let's say that we are working in different projects and we need to swap from one project to the other. Just by closing the solution or just clearing the solution, that deletes all the containers. So we can have the development machine, the resources can be available to work with a different project. We don't need to do specifically anything. We don't need to come here to the console and delete the containers one by one. It is done automatically. although the images are stored so that if we come back, they will be there and we will be able to restart. And something good as well is that if we need to deploy changes very often, meanwhile Visual Studio is open, the container doesn't need to be recreated. So it's like having a virtual machine just there available to us. So the IP to connect to it is not going to change or something like that. So this has been deployed already, and now if we refresh here, we're going to see the customization that we have already deployed. Now IIS needs to restart again. Something I would like to mention, this is being a little bit slow because by default, Docker takes very little resources. And here in this project, we didn't specify how many resources they should take. So basically, the container is running with very little resources. Basically, it's not taking advantage of the resources of this development environment. However, that is something that can be done. Another thing that I didn't mention is that this development environment is running with Windows 10. So basically, it's a normal development environment. We do not need a server or something like that. Okay, this is a very basic customization that we have put in place. Basically, we are just adding here the name of the container, the internal name of the container.
Just a quick question, because
yeah,
from the point of view of the IRS, it thinks basically, or so to speak, that it's running on a Windows Server because it's running on the image on the Windows Server image from Microsoft.
To be precise, we can see that if we go to Docker images, if we go here where the image is defined, and this is pulling from Microsoft ASP.NET Windows Server Core. Okay, so we are using Windows Server Core in the container. Meanwhile, this is loading. I'm going to start introducing the next step in the demo. We have deployed the customization. We will finish it now. And we are going to show next how to debug code that is in a container. This is a very common task and very important. I'm going to show the little customization. This is the little customization that is displaying the code on the home page. Okay, this has been refreshed already. And let's see that we have deployed a little page from TDS. Basically, what we have deployed is as simple as this simple page. Here we are. Okay. So once we have seen the personalization in code and also in TDS, in the Sitecore items, let's see how we would debug this. We're going to attach to the container. We will select the container. And the same as we normally do it, we select the IIS process. We attach. We see that the breakpoint will attach. We refresh this page. And here we are. And we go to the immediate window. We execute one line of code and we jump the existing one in the code. And here we are. We have modified the execution of the container as if we were in a local IIS. Well, that has been the demo. And from my point of view, going to the basics, the three concepts that I would like to be remembered is that Docker can help developers, even though that now is starting and we still have few things to improve, but I really think that it can help a lot in the management of the development process. Also, Docker is arriving to the Sitecore ecosystem. Sitecore has already created two repositories, two centralized repositories, so that the community can start developing and deciding how things should be done or how we would like things to be done. And those centralized repositories are showing that Sitecore is starting to look at Docker, so it's likely that in the future it will develop more and more. Thank you very much. I hope you have found something interesting. If you have any questions now or later, you can reach me and we will do what we can to help. If you want to ask additional questions, please feel free to do it.
Yeah, more general question, I think, with the resources, to configure correctly the containers, how much CRUS and RAM they can take, is there somehow a way to find out how much they actually need? Like with a UI where you can assign the resources, or is it all in the compose file?
Resources can be defined in the compose file. As well, resources can be defined when we run the container. So when we do Docker run container name, you can specify the number of processors that we want for that container, and also you can specify the amount of memory that you want to assign. Here we are not specifying anything, and it is taking the minimum. You can do it when you are running if you do it manually, and you can specify it as well with the Docker Compose. Is there any other question?
Is it faster than a virtual machine overall? So let's say if we have configured the resources correctly.
Yes, exactly. It is faster. It is fast, especially to start. You don't need to start up this operating system, so it starts very fast. It runs as well fast. And taking into account that you are taking less resources from the host, you can optimize, you can have higher density, because you can have more containers with the same host. You don't need additional memory for the operating system. Basically, the container is a process running in the host.
So there might be a chance it might replace sometime in the vast future virtual machine development.
Well, in some scenarios, yes, but not for everything. I mean, virtual machine, having the operating system embedded in the virtual machine might be useful. In fact, there are some hybrid environments where virtual machines, I mean, a host has containers and also virtual machines. And those virtual machines contain inside containers. So there are environments like that. For instance, we might have a virtual machine with a Linux, and we might be running Linux containers within that virtual machine. And the host might be holding the virtual machine, but also Windows containers. Right now, Microsoft is working to support Linux container side by side with Windows container. Up to now, it is possible already to run Linux container at the same time that with Windows container. However, there are some limitations. For instance, I can tell that volumes are not fully supported when we are working in the mixed mode. So even now that it's supported, it still makes sense to run one virtual machine with Linux containers and Windows container all in the same host. Is there any other question? Well, I would like to say as well that these demos, if you want to reproduce it, something that you need to bear in mind is that the sample projects that have been created in this repository are using features that are in the development branch of the Docker images. We might fix that soon, but by now, in order to run the samples, you might need to choose the development branch of the Docker images repository. It's because I've seen some people that are trying to run it and they are getting into issues because they are using the master branch of the Docker images. Are there any more questions? If there are no more questions, thank you very much for joining. I hope that you have seen at least something interesting, and I hope that we have more opportunities to share more meetups. Thank you very much. Have a nice day.